Okay, so if we're looking at the trig form of a complex number, the first thing we have to look at is what is a complex number. And so we've been dealing with complex numbers for many years now in math, but a complex number is any imaginary number in the form a plus bi. And you graph it the same way you would graph a real number, except your y-axis turns into your imaginary axis. You can rewrite any imaginary number in the form a plus bi as a set of coordinate pairs, with a being your first number and b being your second number. Alright, so we're going to look at graphing some complex numbers, and we're also going to look at finding the absolute value of a complex number. So the absolute value of any complex number, a plus bi, is equal to the square root of a squared plus b squared. Okay, so let's look at actually graphing some complex numbers and finding their absolute value. Alright, so your real axis is always your a-axis, which is your x-axis. And your b-axis is your imaginary axis, which is your vertical axis or your y-axis. And so if I rewrite this as a set of ordered pairs, I know that my a value then is -2, and my b value is 5. So I'm just graphing the point -2, 5. Back to up 5. So there, my point -2 plus 5 I would lay in my second quadrant. And if I want to find the absolute value of -2 plus 5i, that's equal to the square root of a squared, and a is -2, squared plus b squared, which would be 5 squared. -2 squared is 4, 5 squared is 25, and 4 plus 25 is 29. So my absolute value would be the square root of 29. Alright, so if I do the same thing for 3 minus 4i, I know that my horizontal axis is my a-axis, and my vertical axis is my b-axis. And so I know that this ordered pair 3 minus 4i is 3 and -4. Then I go over 3 down 4, and I get the point 3 minus 4i. Okay, if I want to find the absolute value of 3 minus 4i, the absolute value tells me to take the square root of my a squared plus b squared. And I know that a squared then would be 3 squared. B squared would be negative 4 squared. Three squared is 9. Negative 4 squared is 16. 9 plus 16 is 25. And the square root of 25 is 5. So my absolute value is 5. Okay, so graphing, finding the absolute value, pretty easy. The last thing that we're going to do is we're going to find the trig form of a complex number. So if you take any complex number, a plus bi, the trig form of that then is when a is equal to r cosine of theta and b is equal to r sine of theta. So then it ends up looking like r cosine of theta plus r sine of theta I. You find your theta by using tangent. So tangent of theta is equal to b over a. And you find your r by finding your absolute value, square root of a squared plus b squared. Okay, there we have that. Alright, so if I look at the complex number negative 2 minus 2 root 3i, I want to write that in trig form. The things I need to find are my r and my theta. Okay, because finding those, then I will have my trig form. So I know that my a is negative 2 and my b is negative 2 root 3. So if I plug those in to find my r, then I get the square root of negative 2 squared plus negative 2 square root of 3 squared. Okay, negative 2 squared is 4. Negative 2 square root of 3 squared is 12. Four plus 12 is 16. Square root of 16 is 4. So I know my r is equal to 4. Then I also need to find my theta by using my tangent formula. So tangent of theta is equal to my b, which is negative 2 square root of 3, over my a, which is negative 2. So then these negative 2's cancel. So tangent of theta is equal to square root of 3. Okay, and so where is tangent equal to square root of 3 on your unit circle? The pig's usually down here. Perfect. So we know that theta is equal to 4 pi over 3 because that's where tangent is equal to square root of 3. So then I know that A is equal to r cosine of theta. Well, my r is 4, and my theta is 4 pi over 3. So my A value is 4 cosine of 4 pi over 3. I know that B is equal to r sine of theta. Well, my r is 4, and my theta is 4 pi over 3. So then I know my complex number is A, which is 4 cosine of 4 pi over 3, plus B, which is 4 sine of 4 pi over 3 pi. Okay, let's do another one. I'm given a complex number 6 minus 6i, and I want to put it in trig form. I have to find my r, which is square root of a squared plus b squared, and I have to find my theta, which is tangent of theta equals b over a. Okay, so I know that a is equal to 6, and b is equal to negative 6. So r equals 6 squared plus negative 6 squared. Which equals 36 plus 36. Which equals the square root of 72. Then I know that tangent of theta is equal to b, which is negative 6, over a, which is positive 6. So if I simplify that, tangent of theta is equal to negative 1. So where's my tangent equal to negative 1? Three pi over 4. So I know theta is 3 pi over 4. Yep, either one. Okay, so if I use that information, I know A is equal to r cosine of theta. And we figured out that r is the square root of 72. And we figured out that theta is 3 pi over 4. I know that b is r sine of theta. And we know that r is square root of 72. And theta is 3 pi over 4. So if I put that together, I get square root of 72 cosine of 3 pi over 4 plus square root of 72 sine of 3 pi over 4 I. Alright, and then the last thing we're going to do is we're going to take numbers that are already in or trig form and change them back into standard form. and this was even easier than putting it in a trig form, because we just have to figure out what these things equal. So cosine of negative pi over 3. What's cosine of negative pi over 3 equal to? On your unit circle, remember you go to pi over 3 and then you flip it to the bottom. Pi over 3? I want to know the, yep, and then tell me the cosine of these 1/2. Okay. So my cosine simplifies to 1/2. And what is sine then of negative pi over 3? Negative square root of 3 over 2. So negative square root of 3 over 2. I'm taking this times square root of 8. Oh. Square root of 8 times 1/2 gives me square root of 8 over 2. Square root of 8 times square root of 3, or times negative square root of 3 gives me negative square root of 24, because 8 times 3 is 24, over 2, and you just move the I to the back. Okay, so let's do the same thing for cosine of 2 pi over 3 and sine of 2 pi over 3. What is cosine of 2 pi over 3? Negative 1/2. Okay, and what is sine of 2 pi over 3? Square root of 3 over 2. Okay, so 8 times negative 1/2 simplifies to negative 4. Then 8 times the square root of 3. You can't combine them, so 8 square root of 3 over 2 I. And then if I simplify 8 over 2, that turns into 4 square root of 3I plus negative 4. 8 divided by 2 is 4, so we can just simplify that fraction to be 4. Okay, so any questions on working backwards? Pretty simple. Okay. You guys are going to work through 476, 5 through 40 today and tomorrow, and then we'll review for your test.